let's look at the sixth dynamic programming problem, PCSES, grid paths. So what's going on here? We have an n by n grid, and some of the squares have paths, walls, I would say. You can't move on those squares. We want to figure out how many paths there are on the upper left, the lower right, and you can only move to the right or down. So we're just given the grid is square, and then we're given the grid, and we can't walk on the asterisks and stars. And we should find the answer plus 7. By the way, if there were no traps, this is just a math problem. The answer is the binomial coefficient 2n choose n. But because there are traps, we can't, it's not really a math problem anymore. We have to actually compute it, right? We have to, it depends not just on n, but on like all of these characters. So the dynamic programming idea, so the brute force idea, right, is just the number of paths on a given square is the number of paths if you go right, plus the number of paths if you go down. That would be exponential. But dynamic programming says, turns that exponential into n squared, because the state is just which square you are. So let's actually do that. So the order on this graph. Column. That. So if we can't walk on the bottom right square, then it's totally hopeless. So if it is a path, then we can't walk on it. So there's 0 ways to get in there. Otherwise, it's just the number of ways down plus the number of ways right. Except that we might go off the grid. We go off the grid, 0. Here. Here. And because we are traversing from the bottom right up, but the important thing is that these cells are filled for this one. But we're traversing C from -1, 0 and R from -1, 0, so that should be true. And we can just print out that's it. So, let's see. just I to go down, you go right. Oh. Okay. Three. That's correct. Cool. Wrong answer. Oh dear. So I think we forgot to do the 10 to the 9 plus 7. Let's do that. Okay. Cool. So yeah, getting the input, convert it from characters to Boolean, false, to if it's okay to walk on. I could have done it the other way, of course. Whichever way is easy if you think about it. And then just doing a DP way instead of, you could also do recursion, both fine. Just decided to do it anyway, just to show you. So, and by anyway, and it's going to be a number of ways to get to the end. So if we're already at the end, it's 1. Otherwise, you just add going right and going down. And you need to check if you're on the right edge of the grid, then the only thing you can do is go down. And if you're on the bottom of the grid, the only thing you can do is go right. So that's what these +1 plus n and c plus 1 plus n checks are for. And also, if the square is not walkable, then we'll just say that it's 0. Note that this handles the case where the start or the end is 0. The end is 0, then there'll be, all these additions will just be adding 0, right? There'll be nothing to start with. And if the start is 0, of course, if 0 is 0, we'll just end up being 0. And then what we wanted to know was the total number of ways to walk from top left to the upper right. So top left is 0, 0, so that's dp 0, 0. Yeah, that's the problem.